Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 3.3 entitled Dividing Polynomials. And today we're going to talk about long division of polynomials and synthetic division of polynomials. We're going to review just a little bit with the long division and then do most of the work with synthetic division. And then we're going to talk about the remainder and the factor theorems and how you can use synthetic division to basically evaluate a big polynomial function. So in this section we're going to study polynomials algebraically, and a lot of our work in higher level math has to deal with factoring polynomials, and in order to factor them we have to know how to divide polynomials. So we're going to talk about dividing polynomials. Now when you divide a polynomial with long division, it's just like your traditional long division process. When you're dividing 38 by 7, you would put 38 inside the box, and then you'd have 7 outside. And you would say, how many times does 7 go into 3? Well, it doesn't. How many times does 7 go into 38? It goes in there 5 times. So 5 times 7 is 35, and then you subtract, and you would have 3 as your remainder. Now, when you were little, you learned to do R3. You do that in like elementary school and middle school. We're more sophisticated now though, so we can write 3 over 7. We write our remainder as a fraction. 3 divided by that 7 that we were dividing by. So you'd get 5 and 3/7 for your answer when you divide 38 by 7. Okay, and this is the book's explanation for the division algorithm. Okay, you have your dividend, you have your divisor, you have your quotient, your remainder. Okay, and the way we write our answer, I'll show you how to write your answer in this format. But I think the way you've learned to write it in the past, where you write it as a sum with a remainder, is a little bit more straightforward than writing it this way, but I can definitely show you how to write it this way as well. So let's practice a long division problem. Now, before you set up your problem, you want to take a look at your polynomial. Okay, you've got 6x squared minus 26x plus 12. We want to make sure that we have all the terms in descending order. And we want to make sure that we have all terms represented. So if I'm starting with an x squared, I need to have an x, and then I need to have a constant, okay, which I do. If I didn't have those, then I would have to have a placeholder. I'd have to have a plus a 0. So I could have plus 0x or plus 0 at the end. And I'm dividing by x minus 4. So when I set this up, I'm going to put the 6x squared minus the 26x plus 12 inside the division box, and I'm going to put the x minus 4 on the outside. Now, just like before, you ask yourself, how many times does this go into this? Or in other words, you say, what do I have to multiply x by to get 6x squared? Well, you'd have to multiply it by 6x. So that's the term that goes up above your very first term inside your box. And then you have to distribute, basically. You have to take the 6x times the x and the 6x times the negative 4. So 6x times x gets you the 6x squared. If those two leading terms aren't the same, you did something wrong. And then 6x times a negative 4 is minus 24x. Now, I always tell my students to put those terms in parentheses and then subtract, because that's basically what you're doing. And sometimes students forget to subtract both terms. They subtract the first two and then they just combine these two. You have to remember that your sign is going to change for that second term because you're subtracting the whole binomial. So the 6x and the 6x, they're going to cancel. And then negative 26 plus 24x will be a negative 2x. And then you bring down your next term, the plus 12. And then you start the process over again. What do I have to multiply x by to get a negative 2x. Well, that would be negative 2. So minus 2 goes up above. And then you distribute negative 2 times the x and negative 2 times the negative 4. So you'll get negative 2x plus 8. And then again, put your parentheses in there and subtract. So the negative 2 minus a negative 2, that's like plus 2, so those cancel. And then you have 12 minus 8, so that's going to be a 4. And you don't have any other terms to bring down, so 4 is going to be your remainder. And we're going to write that as plus 4 over x minus 4, which is what you were dividing by. It's plus 4 because this 4 is positive. If the 4 was negative, you would have put minus 4. Okay, so that is fine to write your answer that way for me. That's totally fine. Your book will write it slightly different. Okay, they'll take the 6x minus 2, the whole number, so to speak, all the stuff before the remainder, and they'll put that in parentheses. And then they'll multiply it by what you were dividing by, the x minus 4, and then they just write the remainder behind it, plus 4. So that's just another way to write the answer. So if you want to leave your answer as I have here in the long division part, or if you want to write it like the book does, that's totally fine. Just remember that the first part is the whole part of your answer from your quotient. It's the non-remainder part of your quotient. And then this is what you were dividing by, and then you have your remainder at the end. Okay. Now, nobody likes to do that much work for long division, so we came up with this synthetic division process. It's quick and it's easy, and synthetic is fake. Synthetic oil is fake, man-made stuff, and that's basically what synthetic division is. It's fake. We don't divide at all. We multiply and we add and subtract. There's no division. Okay? So here's how we compare long division and synthetic division. So this is all the work that we'd have to do for our long division process if we were dividing 2x to the third minus 7x squared plus 5 by x minus 3. And we would go through each step just like we did on the previous page. With synthetic division, you're only using 3 lines. And you organize your work in columns. You just use the coefficients. And you put the opposite number of what you're dividing by. Here they have an x minus 3, so you put plus 3 up front. And then you basically put a 0 here in this first spot, and you add down the column. And then you do 3 times 2 is 6, so that goes there. And then you add the negative 7 and the 6 to get the negative 1. 3 times negative 1 is going to be the negative 3. Add that with the 0. That 0 was there for a placeholder. So you get the negative 3. 3 times negative 3 is negative 9. And then you add that with the 5, and you get negative 4. And that last term there is always going to be your remainder. Okay? And then these are going to be the coefficients for your answer. So your answer will be 2x to the second minus x minus 3. Your answer is always going to start 1 degree less than what you began with. So if we started with 2x to the third, you're going to start with 2x squared for your answer. Okay, so these are the coefficients of our answer. Okay, so let's go through one ourselves now. So again, I'm dividing 2x to the third minus 7x squared plus 5 by x minus 3. So I have an x to the third and an x squared. I don't have an x term. I'm missing that x term. So I have to put a placeholder in there. And then I'll have my 5. Okay? So I'm really doing 2x to the third minus 7x squared plus 0x plus 5. That's my polynomial. Okay? So I'm going to take the coefficients for each term and put them in my first row of my long division, or I'm sorry, synthetic division process. Now your book puts all of that inside a big box to divide. I don't like to do that. I like to put a little box outside that I put what I'm dividing by in. And remember, if I'm dividing by x minus 3, then I want to put the opposite of that number into this little box here. So instead of dividing by x minus 3, I'm going to divide by x plus 3, and you just put the number, so just 3. Okay. And then you put a 0 for a placeholder, and then you draw your equal to line, and now you're all set up and you're ready to go. So 2 plus 0 is 2, so you add down the column. 3 times 2 will be 6. Negative 7 plus 6 is negative 1. 3 times negative 1 is negative 3. Plus 0 is negative 3. 3 times negative 3 is negative 9. Negative 9 plus 5 is 4. Oh, negative 4. Okay, so again, that number at the end, that's always going to be your remainder. Sometimes you'll have one, sometimes you won't. If you don't have remainder, you just put a 0 there. Okay? And then to write your answer, you start 1 degree less than what your degree was for your original polynomial. So we had 2x to the third, so this will be 2x squared, because we have 2 here, 2x squared, minus 1x, because in descending order, x comes next, and then the minus 3 will be my constant, and then my remainder will be minus 4 over what I was dividing by, x minus 3. Now again, you can write your answer like that. If you want to write your answer using the book's method, you would have, let me write it up here, you'd have the whole part of your quotient, meaning the non-remainder part, you have that in parentheses, times what you were dividing by, and then you add on your remainder at the end. Or in our case, we put minus 4 because it was a negative 4. Okay, so if you want to write your answer like that, you can. If you want to just leave it in your format that you're used to, that's fine as well. Now, the downside of synthetic division is that it only works with binomials for divisors. So when your divisor is a binomial, like we had here, we had the x minus 3, that's the only time that you can use synthetic division. So that's the downside of the synthetic division. Long division you can use with any divisor. Okay, so let's go through this one. I have an x to the 5th, x to the 4th, x to the 3rd, x, and then my number. I'm missing an x squared. So I'm going to need to add in a 0x squared when I set up my long division. And now I'm dividing by x squared plus x minus 1. So I've got a trinomial here. I can't do synthetic division with the trinomial, so I have to do long division for this one. Okay. So I'm going to set up my x to the 5th plus x to the 4th minus 2x to the 3rd plus 0x squared plus x plus 1. And I'm going to divide it all by x squared plus x minus 1. Okay? Now you start off the process the same as we did before. You say, what do I have to multiply x squared by to get x to the 5th? That's going to be an x to the 3rd. And then you're going to distribute that x to the 3rd to all 3 of those terms in your divisor. So I'll get x to the 5th plus x to the 4th minus 1x to the 3rd. Now your degrees should line up in your columns here. You've got an x to the 5th, x to the 4th, x to the 3rd. If that doesn't happen, you either did something wrong or you missed a placeholder. So go back and check your work. And again, put that stuff in parentheses and then subtract. Okay, it's a good habit to do that so you don't miss any sign changes. If you miss a sign change here, you're going to mess up the whole rest of the problem. Okay? So that x to the 5ths cancel. X to the 4th minus x to the 4th. Oh, sweet. Those cancel too. Nice. And then I've got a negative 2x to the 3rd plus x to the third because it's minus and negative. So that's going to be a negative 2 plus 1 is negative 1 x to the third. Then I'm going to bring down my 0x squared, and I'm going to bring down my x. I have to have 3 terms here. Now, if the x to the fourths hadn't canceled, then I'd have an x to the fourth and an x to the third, and I would just bring down the 1x squared, or the 0x squared. Okay, but you have to have 3 terms there. And then you start the process over again. What do I have to multiply x squared by to get a negative x to the third? That's going to be negative x. So negative x times x to the squared, or x squared, is negative 1x to the third. Negative x times negative x is negative x squared. And then negative x times negative 1 is positive x. And then again, you want to put those in parentheses and subtract. Okay, remember to do that so you change those signs. Now my x to the thirds are going to cancel. I have 0 plus 1x squared, so I get my 1x squared. And then my x minus x, oh, those cancel. Nice. So then I'm going to bring down my plus 1. Now I'm leaving a little gap here on purpose because I'm missing that term. So if you wanted to fill it in with the 0x plus 0x, you could. Okay? And I can only bring down one term this time because that's all I have left. Okay? So I have to go through my long division one more time now. I have to ask x squared times what is x squared? That's a 1. So I'm going to put plus 1 up at the top. So that'll get me a 1x squared when I distribute. 1 times x is going to be an x. And x times negative, or I'm sorry, 1 times negative 1 is going to be a negative 1. So when I multiply the 1 by my trinomial, I do get a trinomial down here. So that's why we want to have that placeholder of the 0x in there. That way I don't accidentally line up my x term with my constant term. So one advantage of the long division is that you have to stay organized. You have to keep all your columns very well aligned. You have to be nice and neat. Sometimes students do this on graph paper so that they can use the little boxes to keep everything lined up. Okay, so 1x squared minus x squared is nothing. 0 minus 1 is negative 1x. And then 1 minus negative 1 is plus 1, so that'll be plus 2. So now that whole term, that whole binomial is going to be my remainder. So it's going to be a little tough to squeeze it in up here, but we'll have plus, because it's well, it's negative, but it's only negative with the x. So I'm going to leave it plus a negative x plus 2 all over x squared plus x minus 1. Okay, so that's totally fine with me to do. If you want to put plus and then the negative in there, if you put minus, then you'd have to change the sign on the 2, or you'd have to put something in parentheses. So a good rule of thumb is, when in doubt, when you have a binomial here that is your remainder, just put plus and then just write the binomial or the trinomial remainder over what you were dividing by, just to be on the safe side. Okay. All right, that was just extra room if we needed it. Now we've got 2 last concepts, the remainder and the factor theorem. Now, the remainder theorem is pretty cool, okay? It says that when you divide p of x, some polynomial, by x minus c, the remainder is going to be whatever p of c is. So that means if you took this number c, not the negative, but just the c, and you put it into the polynomial function, the value you get out is going to be the same as the remainder as when you divide. So if you do the long division and you get a remainder, it's the same as the value of the function at that value that you're dividing by, which is pretty cool. It's a pretty cool coincidence. So let's take a look at that. Okay. So for part A here, it says to find the quotient and the remainder when your polynomial is divided by x plus 2. Now, here again, we have a binomial that we're dividing by. So that means I can use synthetic division, which is good. So this is going to go really fast. Because here's my huge polynomial that I have to divide. It's a 5th degree. Then I have the 4 and the 3. I don't have my x squared, so I need a 0x squared in there. And then my 7x, and then my 3. So I'm going to need a placeholder here when I set up my synthetic division. So I'm going to have 3, 5, -4, 0, 7, 3. And then the number that goes in the box, remember, is going to be opposite of what you're dividing by. So -2. I put my 0, and then I start adding and multiplying. So I add the column, and I multiply by what I'm dividing by. Add the column, and multiply. Add the column, and multiply. Multiply, and add. And then when I multiply here, I get a 2. And when I bring my sum down, I'm going to get 5. Okay, so my remainder is 5. Now, on the next slide, we're going to try substituting. Okay, so I'm dealing with the same polynomial, I'm dealing with the same divisor, except if I'm dividing by an x plus 2, that's what we were dividing by, right? Yep. So if I'm dividing by an x plus 2, the number that actually goes inside the box is a -2. So that's the number that I'm going to substitute into this big polynomial. And we're going to see what happens. So I'm going to have, whoops, equals 3 times -2 to the 5th, and 5 times -2 to the 4th, and 4 times -2 to the 3rd, and 7 times -2 plus 3. So this gets a little tedious, but if I multiply this out, I'm going to get -96. Multiply this out, I get 80. Multiply that out, I get 32. Multiply there, I get -14, and then the plus 3. And when I combine those terms, I'm going to get 5. So the point here with this is that instead of doing substitution, where you're taking a value and substituting it into a giant polynomial with, in this case, 5 or 6 terms if you count the plus 0x squared, okay? And doing this tedious calculation where you're simplifying each term and then adding and subtracting them, you can just do synthetic division. And the remainder that you get is the exact same as the value you get when you substitute. Okay? So synthetic division not only divides polynomials, but it can evaluate them for you as well. Okay, so the last concept we're going to talk about is the factor theorem. Now, when you do synthetic division, when you divide a polynomial by a binomial, and you get a remainder of 0, that tells you that what you were dividing by, that binomial, is a factor of the original polynomial. Okay, so we're going to prove that here. Okay. It says our polynomial is x to the 3rd minus 7x plus 6. Notice that we're missing a term here. I go from x to the 3rd to x, so I'm missing that 0x squared. And they want me to show that p of 1 equals 0. Now I'm not going to put 1 in there and substitute. Okay? I'm going to do the synthetic division. So I'm going to, if they want me to put 1 in, then 1 goes in the box. And then I'm going to have 1x to the 3rd, 0x squared, minus 7x plus 6. So when I set up this first row in my synthetic division, remember it's just the coefficients from my polynomial. And then I add down, and then I multiply. Look at that. I got a remainder of 0. Okay? So that tells me that x minus 1, because that's the binomial that I'm dividing by. If I have a positive 1 here inside the little box, that means that x minus 1 was a polynomial that I was dividing by. And whatever else my answer simplifies down to. So my answer that I got here, let's see, I started with x to the third, so this is really x squared plus x minus 6. So that's my trinomial that I get when I divide my original polynomial by the x minus 1. But this is factorable, okay? It says factor completely. So now I have to do guess and check. Find the factors of 6 that get me to 1. So I'd need a 3 and a 2. And to get to a positive 1, I'd have to have a positive 3 and a minus 2. Okay. So once I get my solution, then I'm going to factor that, and I have to count the factor that I was dividing by. So now I have a completely factored polynomial. Okay, so synthetic division has a lot of uses. It can help us do faster substitution. It can help us to completely factor a big polynomial, or a polynomial that has a really high degree to it. That was just extra room if we needed it to work. And there's your homework for tonight. Okay, a little choppy, looks like it's a little long, but a lot of it is with the synthetic division. Okay, there are directions for doing long division by hand and synthetic division by hand. So try the long division. You should not need a calculator for any of this stuff. Okay, on your quiz and on your test, you're going to have a section where we don't give you a calculator. So you're going to have to know how to do all of this by hand. So do it by hand. Practice it on your homework without a calculator. Okay, and remember that I have all the work in the binder in the classroom. And if you have any questions, stop on in before school and see me.